Welcome to Activity 5.3. This is Lesson 5. This is the PS2 book. And if you're looking in your book, you should be on page 54. And our learning target for today is we're going to analyze data to determine what makes a pendulum stop. So the expectation for you is you will gather data to complete the data chart and graph on page 55, as well as all the questions on pages 55 and 56. Now, think about what we've been doing in class. What are some things that you've seen during this unit so far that slow down and stop gradually? Can you think of anything? Well, the bouncing ball that we did outside, eventually they stopped bouncing. The pendulums that we've worked with. Anything else? Okay, so what we're going to do is we're going to continue to take a look at why things stop. So when we deal with the pendulum, the first thing I want you to do on page 55, on page 54, is I want you to make a prediction. What will happen to the pendulum while it swings? So we're going to use a pendulum. We're not going to use pendulums here in class, but we're going to use computer simulated pendulums. But what do you think will happen to a pendulum while it swings? So what are your predictions? So go ahead, pause the video, and take a few minutes to make a prediction. All right, so what is your prediction? Did you predict that it'll swing forever? Did you predict that it will stop eventually? Well, we're going to find out today. So the first thing I want you to do is turn to page 55 in your book, and there is a chart. What I want you to do on the left-hand side is to write in 20, 40, 60, 80, and 100. What we're going to do, and I'll give you the link should ask me for the link if you don't have it, otherwise I'll place it in Google Classroom along with this video, is you're going to look at an online pendulum and you're going to count how many you're going to count the swings. You're going to count up to 20 swings and 40 and 60 and 80 and 100. What you're going to be doing is you're going to be looking for height, and you can see that right here, height of the swing. So first thing I want you to do is I want you to look over everything on this sheet. This is all your procedures, because you're going to need to know this, because I need everybody to do this experiment or this lab the exact same way. That way all of our data is comparable. So you're going to use a computer model, and here is URL shortener, but I'll give you the link in Google Classroom as well. So you're going to use a computer to model the pendulum motion. You're going to release the bob, and that's what the end of the pendulum is called. It's called a bob. So it's not some guy named Bob. We're not releasing Bob, or Robert or anything like that. At the end of it's called a bob. So we're going to release the bob at 70 degrees so the pendulum swings. You're going to count 20 swings from side to side, and I'll show you what this looks like in a few minutes. You're going to record the highest point the pendulum reaches on the 20th swing in your table. And if you look at your table, it's every 20 swings. You're going to stop it, and you're going to measure that height. Now here's a hint, and I'll show you how this works too in a minute. Between swings 19 and 20, slow the pendulum speed down to 1/16. Then it'll be much, much easier to stop. And if you look for the kinetic energy, it'll reach 0. That's when you know it's time to stop for sure. Now, if you're a little off, you should still be okay. So you don't have to restart it if you're just a fraction of a second off. Now, here's something that's going to be a little tricky. You're going to measure the height of the pendulum where the rope attaches to the pendulum. And they're going to use a ruler to measure across the computer ruler. So, or measure across your screen, and I'll show you what that's going to look like, or I'll tell you how you're going to do it, because you can't actually see me do it. And to determine the height, you're going to use 200, or take 200 minus your reading, and that'll equal the pendulum height. So then you're going to record your measurements in a data table. Now this is important. Do not reset the pendulum. Just hit play and it will continue to swing. So then you're going to count 21, 22, 23 until it reaches 40. Then you're going to stop it again. And this is important because every year I'll have students that will just completely reset it, and then they'll never get done. They'll never reach 40, or they'll count 20, then they'll reset it, then they'll count all the way from 1 to 40, and then they'll reset it and they'll count all the way from 1 to 60, and it just takes way more time. So any questions so far? So let's take a look. Here is this website. This is what you're going to be on. So this is what we're going to be using today. Now first of all, let's look at our settings. Your length you shouldn't have to redo anything. It should be at 2 meters. Your mass is going to be at 1 kilogram. Now, you shouldn't have to touch anything here. All this does is if you click on this, it would show 2 pendulums. We don't want 2 pendulums. Now, if you get done early with everything, you can always come back. You can play with it. But don't come back to this until you completed the entire lab, including the questions. Because every year I'll have people who aren't done. I'll say, well, what did you do? Oh, we played with the pendulum. Well, then you didn't do your work. Friction. Now watch this. If I get this going, right now with no friction, it'll go to the exact same spot every time. So what we're going to do is we're going to change our friction so that's at the halfway mark. Now if I put it all the way, you'll see that it's going to stop really quickly. So everybody needs to have their friction halfway. Now remember when I was talking about you can slow down, so I can pause it here. If I click on this 1/16th link right here, look how slow it goes. So this will give me a chance to get things stopped right where I want. Otherwise, I'm going to have it in real time. Now, one thing I notice now is that once you click this, it starts moving right away. So you're going to have to hit play and then pause again. Now, we are on the Earth, so we should have Earth clicked. Again, later, if you get done with everything in your lab, you can come back here and see what the pendulum would look like on the Moon and Jupiter, on planet X, and if gravity equals 0. Now, when it says show velocity and acceleration, that's all it's showing right here. It's showing these arrows. So you shouldn't really need those on at all. One of the things I do want you to click is this one right here. What this does is it shows you the kinetic energy, the potential energy, which is your GE, thermal, because we haven't talked about it yet, but it's there, and your total amount of energy. So you can see when I let this go, and I hit play, that as it's coming down, KE is increasing, it's going down, and as it's going up, your KE is decreasing. And with potential gravitational energy, it's just the opposite. And then here's your thermal energy. So the longer it goes, the warmer it gets. Here's your total amount of energy. The total amount of energy does not change at all. Okay? So once you have all these things set, you're going to be ready to begin. First thing, however, you need to do before you begin is I want you to set this ruler right here and set the very top at the circle here. Now, if I hit reset here, it's right here. Now, it's not perfectly at the bottom, but as long as everybody does it the same way, your data will be comparable to everybody else's data as we're doing this lab. So this is what you need to do. You need to take your pendulum, once you have everything set, and if you look at the top, it'll tell you how many degrees it is. I'm going to take it right up to 70. Now what I'm going to do is I'm going to let it go and I'm going to start counting. So you guys ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So now I'm going to slow it down to 1/16th time. And what I'm doing is I'm looking. As it starts to go up, the KE should come down. And I'm going to wait for that KE to be perfectly at 0 or as close as I can. So I should start to see that KE is shrinking. I'm waiting for it, waiting for it, waiting for it, waiting for it. Okay, I'm going to pause. Now what I'm going to do is I want you to put a piece of paper, could be a ruler, but I think a piece of paper would probably be more flexible, and hold it right up to where the pendulum meets the bob and have it go straight across. So when I look at this, my measurement is about 110. So remember what we had to do. So I have to take 200 and subtract 110, and that will be my measurement. So right now, from here to here is approximately 90 centimeters. So go ahead and record that in your data table. Then what I'm going to do is I'm going to put it back in real time, and this is 20, so this will be 21, 22, 23, 24, 25, so on and so forth. So I'm just going to go ahead and pause it. So don't reset it each time. So then you're going to go out to 40, 60, the 80, and the 100. And by the time you're done, you should have all this data filled in. Now, once you get all the data filled in, you need to go to the bottom of the page, page 55, and you need to finish the conclusion. So in number 1, use the data in the table, construct a graph of the maximum height versus the number of swings. Then you're going to answer questions number 2, number 3, number 4. Don't forget to flip it over. There's more questions in a follow-up. You're going to have to finish questions 1, 2, 3, 4 in a follow-up on page 56. So once you finish up this lab, just let your teacher know if you've been absent. That way they can check it off that you are done and check for understanding. Or if you have any questions, make sure you check with them. So again, this is activity 5.3 out of the book. Thanks.